Welcome back, geologists. So today we're going to talk about texture, and we're going to talk a little bit about what's in the book, and then I'm going to add a little bit of extra information for you just on the outside so you kind of have a better idea of what's going on. So on that note, let's go ahead and get started. Texture. Different igneous rocks may have similar mineral compositions and yet have very different textures. The texture of an igneous rock depends on the size and shape of its mineral crystals. The only exceptions to this rule are the different types of volcanic glass, igneous rocks that lacks a crystal structure. Rapidly cooling lava forms fine-grained igneous rocks with small crystals or no crystals at all. Slowly cooling magma forms coarse-grained rocks such as granite with large crystals. So, intrusive and extrusive rocks usually have different textures. For example, intrusive rocks have larger grains than extrusive rocks. Extrusive rocks have a fine-grained or glassy texture. Figure 1 shows the textures in different igneous rocks. Alright, so we're going to do your notes a little bit different than we normally do for texture. Instead of pulling out the, talking about slowly cooling rocks and rapidly cooling lava and whatnot, we're going to talk about coarse-grained and fine-grained. So, coarse-grained rocks, or coarse-grained texture is better. Coarse-grained texture forms, I'll try that. Oh, there it went, go look. Coarse-grained forms from slowly cooling magma. Forms from slowly cooling magma and with large crystals. So, and underneath that, I'm going to give an example of a rock that's coarse-grained, and it shows that granite was an example of a rock that's coarse-grained. So, I'm also going to put one other thing underneath coarse-grained. In our reading, it talked about how, for example, intrusive rocks have larger grains than extrusive rocks. So that tells me that intrusive rocks tend to be coarse-grained. So I'm going to put intrusive rocks have a coarse-grained texture. And that makes sense. Slow cooling, so if it's something slow cooling, it has more of an opportunity to grow. So if the magma is slow cooling the way it is, the crystals have a chance to get really big. The other texture that's really important from the reading is fine-grained texture. And that forms from rapidly cooling lava with small or no crystals. In the example that it gave us, well, it doesn't really give us an example, but I'm going to give you one of the salt. We've looked about that. We looked at that a lot already, too. We looked at it with extrusive rocks. So from our reading, it tells us extrusive rocks have a fine-grained or glassy texture. So I can put underneath here that extrusive rocks have a fine-grained texture. So now we've talked about coarse-grained and fine-grained. But I want to kind of draw your attention to this picture down here. It's got a picture of a volcano, and it's got 3 different rocks, goodness gracious. So I'm going to start over here. Rhyolite. Rhyolite is fine-grained extrusive igneous rock with a composition that is similar to granite. And what it's asking you is to determine if this rock forms from A or B. So to answer this, we have to talk a little bit about the difference between magma and lava. So magma forms down here in B. And it's kind of this hot, fluid, semi-fluid, sometimes it has like rocks in it and whatnot, that is beneath the Earth's surface. And so this magma, it travels up, and then it shoots out, and once it's shot out and it's on the surface here, it is lava now. It's a fluid from which lava comes from. Or magma is the fluid that lava comes from. Magma becomes lava when it hits the surface. So, if rhyolite is a fine-grained, extrusive igneous rock with a composition similar to granite, if we know it's fine-grained but an extrusive, that means that it happened outside. So it happened at A, lava. Now if we go down here to pegmatite, a very coarse-grained, intrusive igneous rock. If it's very coarse-grained and it's intrusive, that means it happened inside the earth. So that means it's down here at B. But what about porphyry? The porphyry shown here has large crystals surrounded by small crystals. Where do the large crystals form? Well, we can answer that question. We know that the large crystals form down here in the magma because that's where large crystals come from. The slow cooling magma makes the crystals become really big. But where on earth did those small crystals come from? Now the book doesn't explain it, but I feel it best to kind of give you that little extra information. It's going to help you in the long run. So these small crystals, large crystals and small crystals that are in porphyry, come from two different places. The large crystals form down here in the magma, but the rock's not completely done forming when it shoots up out of here and it hits the lava. When it hits the lava and the small crystals come. And it actually forms from a special place called pyroclastic flow. Now you're probably wondering, what on earth does that mean? So let me read pyroclastic flow to you. This is a website that I found. It's Kids Fun Science, but it has stuff from very credible sources. So it says that, introduction, watching pyroclastic flows traveling down the side of a volcano at hurricane speeds are awe-inspiring sights. They occur during large volcanic eruptions. At the beginning stages of a large eruption, a column forms over the vent of the volcano. The vent of the volcano is the hole at the top where the lava shoots out. The eruption column blasts superheated ash and rocks high into the atmosphere. So from that introduction alone, we can already pull out kind of what a pyroclastic flow is. And if you look down here, this gives you a good definition of it. So pyroclastic flows are flows of superheated ash, rock, and other debris that flow down the side of a volcano at hurricane speeds. And so from this pyroclastic flow, we get this weird, like, two distinct grain sizes in this rock that has these large crystals and the small crystals. And the type of texture that this is, it's not quite coarse grain, it's not quite fine grained, it's called porphyritic texture. So I'm going to go over here and I'm going to, oh, what did I do? Continue out. I'm going to go ahead and add this to the notes. I'm going to add if I can even spell it. Oh boy, I gotta look. Porphyritic texture. And it forms from pyroclastic flow with large crystals surrounded by small crystals. So then I'm going to make sure that I define what pyroclastic flow is, because if you're anything like me, you're going to forget what it is. So a pyroclastic flow is the flow of superheated ash, rock, and other debris that flows down the side of a volcano during an eruption. So just so I remember, looking back, a pyroclastic flow is the flow of superheated rock, ash, and other debris that flows down the side of the volcano. And an example of a rock that has porphyritic texture is porphyry. Porphyry has a pyroclastic texture. So in this, we have coarse grain texture that have those real big crystals in it that form inside the earth with magma, slow cooling magma. And then you have fine grain that have the real small crystals or no crystals at all, and they are formed on the outside of the Earth with the rapidly cooling lava. And then we have porphyritic texture, which forms from pyroclastic flow with large crystals that are surrounded by small crystals. So, on that note, guys, we are done with texture. I will see you again for mineral composition very soon. Good luck!